see what the counting principle is and how we can use it to count choices. In the game of Clue, which is a board game where contestants try to guess who is the murderer, what the weapon was, and in what room did the murder occur, is a classic situation where you have a lot of choices for each of those, and you might want to know how many possibilities are there to mix and match these. And we've talked about problems like this before, but today we're going to extend it to probability problems. So let's start by talking about what I called the slot method before, where you say we have people and weapons and rooms, right? Well, when you take the number of people, which in this case is 6, and you take the number of weapons, which is also 6, and the number of rooms, if you want to know how many combinations of all those things, you multiply that. This method has a name, and it's called the counting principle. If you want to count up how many choices there are, which we often need to do to determine how big a sample space is, and we're just going to multiply those 3 numbers together. That is 324. So there's 324 ways to mix and match these parts of the game. Now, how do we use that for probability? Well, probability is a ratio. Both parts of the ratio can use the counting principle. So let's look at this. Probability that the conclusion is that a female person did the murder using a metal weapon and performed the murder in a kitchen or dining room out of all the rooms there. So let's see what the probability was. There's 2 ways to look at this. We can use our previous number because actually that's all the possibilities. So our probability is over 324. To get the numerator, you use the counting principle again, but this time you look at how many females are in the list. So in this case, we've got Mrs. Peacock, Scarlet, and Mrs. White. That's 3 choices times metal weapons, lots of metal weapons. We got the candlestick, the knife, the lead pipe, the revolver, not the rope, and the wrench. Those are metal, 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 metal. So that's 5 different things. And then we're going to multiply by kitchen or dining room. This is one of those and or situations. And you don't have to overthink it. That's clearly just 2 rooms. But another way to look at it is that it's 1 plus 1. When you see the word or, you add those things together. We just multiply that out. And that's 15 times 2, which is 30 over 324. And that does need some reducing. I think we can divide by 6, both top and bottom, to reduce it down to 5 over 54. Okay, there's one other way to do it. It's also using the counting principle. I always like to show you more than one way so you can choose which way you're more drawn to. When you look at the counting principle in the top, I would write down the same thing. I have 3 choices times 5 choices times 2 choices. If we hadn't already done this problem and you were starting from scratch, you could write down 6 choices times 6 choices times 9 choices in the denominator. And you could actually think of this as, for women, I have a 3 out of 6 chance, times metal weapons out of weapons is a 5 out of 6 chance, and kitchen or dining room is a 2 out of 9. And if you're multiplying all those things together, you can cross cancel all you want. So is there any reducing you can see? I can see lots. So I'm going to reduce by 3. So I divided 3 out of both of those. And I could divide 2 out of this and 2 out of this. That's all the reducing I can see. Now if I multiply what is left, I get 5 out of 6 times 9 is 54. Same result either way. And that's kind of a combination of different ways, but it's all based on the counting principle. If you have choices for different things, you multiply the choices together to get all the possible combinations of choices at the end. That should help on some of the problems in this unit.